Okay, so the next lesson would be solving one-step equations with multiplication and division. So we're going to be using inverse operations again, and I will remind you that multiplication and division are inverse operations. So I see 3x, that is multiplication, remember, letter, variable is multiplication. So the opposite of multiplying is dividing, so I'm going to divide both sides by 3. That'll tell me that x is 6. And yes, you must show the work. Yes, we're doing this for a reason. I know if I asked you what times 3 is 18, you're going to be able to tell me 6. That's not the goal here, really. This is giving you the foundation to be able to handle more complex stuff in Chapter 10, Chapter 2 of Algebra 1, all of Algebra 2, Geometry, Algebra 3. Just trust me. Next is d divided by 5 equals 4. This is showing me division, so I'm going to multiply by 5. 4 times 5 is 20. Divide both sides by 2 on this next example to find out that z is 17. This next guy is division. H sevenths is division. Remember, we can represent division as a fraction. And this is more often than not how you'll see it. Like the division symbol examples you're seeing are not going to be very common going forward. So we will multiply both sides by 7. 8 times 7, of course, is 56. What number times 5 is 35? 7. How do I show that? Divide both sides by 5. What divided by 8 is 1? 8. How do I show that? Multiply both sides by 8. It's not so much that figuring these out is difficult. I really don't think it is. You've been doing things like this for years and years and years. It's just getting you in the habit of showing work the way it needs to be shown going forward. I need to do a couple of these so it'll let me write and not freak out on me. Two-step equations. So we're not going to see a lot of these yet. We'll see a lot more in Chapter 10. But they're going to sneak one or two in on you. So how do we handle these? Reverse PEMDAS, if that makes sense. So there's going to be a number that is essentially superglued to the variable, whether that's multiplied or divided. And there's going to be a number that's velcroed to it, and that's addition or subtraction. I think we'd all agree that undoing Velcro is much easier than undoing superglue. So, how do I undo the Velcro of plus 1? By subtracting 1. That would get me 2x equals 16. Still 2x because I haven't touched that thing yet. I only subtracted 1. Now this is a one-step equation. We would divide both sides by 2 to see that x is 8. Okay, this is why I stress showing the work and doing the process. Because if I tried to explain this to you, I'd say, okay, I'm going to double a number, and then I'm going to add 1, and I'll have 17. What's the number? You can figure that out, and you're going to do it exactly what we did. You're going to take 1 away from 17, then you're going to divide by 2, but it's all about showing that process. So on the next one, the Velcro, for lack of a better term, is the minus 2. So we'll start by adding 2 to both sides, and that gets me d fifths equals 5. Remembering that a fraction shows division, I will multiply both sides by 5 to find out that d is 25.